Hi everyone. Good morning everyone. Yes, so today we are going to start the subject software engineering, right? Code of it is TCS 510, right? So as today is the first class, so what we'll do, we'll just quickly see the syllabus, entire syllabus. I'll show you what we are going to study and how we will approach. This all we'll cover. Then just introduction part, what is engineering, what how software engineering came into action, and what is the difference between a simple program which you must have written in previous semesters, right? And so what is the difference between program and software? What is called as software and what is program? So basically difference we'll see both of it, right? So let's start. So this is the syllabus in which the unit 1 contains introduction part, history, how evolution came, then crisis, basically how in unit 1 we'll study SDLC part. SDLC means later on you get to know everything, but just listen once. Okay, so SDLC means software development life cycle. So to develop any software is what? Collection of programs. So to develop any software, there is entire team involved in it, right? So the task is divided inside the team. Like someone will be doing the coding part, someone will be doing the designing part, someone will test, and then maintenance team will also be there, right? So these everything's are divided into the phases, and each phase come one by one, and overall it is called as a life cycle or model, developing model it becomes, right? Later on you will get to know it. So these are the models, right? Code fix model, waterfall model, evolutionary model, these all are the models, and at last we will study all the comparisons among the models. Okay. Better. Yes. In unit 2 what we'll study the requirement phases comes under the unit number 2. Requirement means whatever we are going to develop, whatever means the software which we are going to develop, how the requirement will be analyzed and how the SRS will be made. SRS means software requirement specification. What are the requirements, how we will analyze it, and because the backbone of any software is how the SRS is made, right? So in unit 2 we'll study everything about the requirement phase. Now comes unit 3, designing part, comes under software. So unit 3, designing part comes under the unit number 3. So in unit 3 we'll discuss about the designing part. Later on in unit 4, see in unit 3 itself we'll see how the coding is done. That comes under development phase, development part. What are the guidelines and how the coding is done. See, you might get confused that coding is itself is everything about the development of the software. No, it's wrong. It's just a one part of it. Coding doesn't mean that you are going to develop the software. Coding is just a small part or a small step of a development of a software, right? So unit 4 entire covers the total testing, how the testing is done. different types of testing are there. When we will approach to this, we'll study everything over there, right? And the last unit is maintenance part, how the maintenance is done. Cases to case tool are there, some quality checking models are also there, we'll discuss it over there. So these are the total 5 units we have, and the things which we are going to study in this are these. Okay, now the question arises first is, what is software engineering, right? Here it, yes. If entire building is to be developed, it is not possible for a single man. A team is required, right? That is why it is called a systematic collection of past, which I have already told you that a certain approach is decided based on the past experiences, right? Experience include technique, methodologies, and guidelines. Both, all the three things are considered, and one approach is followed, and that is called as engineering approach. Correct. So I think it must be clear that what is the software engineering. We can also say that a discipline whose aim is the production of quality software that is delivered on time, within budget, and that satisfies its requirement. See, whenever customer reaches to you or any organization, what it wants, it gives you certain requirements, and your software must match to all those requirements, then only it will be considered by the customer, right? Now, if it is a good quality software, how it is can be considered as good quality? There are certain models, Kokomo and software quality, like CMM, other. We will study that. Just listen to now that quality software means in which errors are less, or error identification is easier. It is called quality software, correct? And if it is delivered on time, it should be developed within the time limit, because if it exceeds the time limit, the budget is going to on the higher side. Why? The labor cost will increase, correct? Infrastructure will be taken, correct? Yeah, within budget, then only it will be in the budget. So this is the discipline for software engineering, or we can say software engineering is a discipline whose aim is the production of quality software within time, on budget, on time. Yeah. Next, this is the pattern which is shown through the graph. Here it is technology on the y-axis, and on the x-axis it's time given. According to time, technology evolves and engineering also evolves. Engineering refines. Why? Based on the past experiences, one suitable approach has been decided here, right? See, it is unorganized use of past experience. That is why it is, the curve is not going only upwards. It is just one time it's down, then up, down, then up. That is why it is unorganized. So based on all the experiences of the past, when a certain approach is decided and it is used, then it is termed as the engineering here. See, the optimization is at the highest level, and production productivity also becomes high, and technology also increases according to time, so the output will also be high here, correct? So the last thing today we'll discuss only is difference between a program and software. See, you all have developed a program in first year. So what is program? Program is usually small in size, can be developed by single user, correct? Whereas a software is what? It is huge collection of programs, correct? And when they are what? They are linked to each other. Each like collection of programs, and programs parameters are also linked, or functions are also linked, then only it becomes a software. All the programs are connected, right? So there are large number of users because our team is decided and a role is given to a specific user to do. So a large number of user is required. There is a team of developers, right? यहाँ पर here single developer is here in developing the program. It's very easy, you also know. You can analyze this, nothing complex here. Lacks proper user interface, well defined interface. It is obvious, as the size of the program increases, the single user might get difficult to optimizes, difficult to get proper interface, and difficult to do proper documentation also. It will also lack in proper documentation. Whereas when number of users and proper team is there, role is assigned there, proper well documentation will be done here. Ad hoc development means based on certain idea. Let's suppose mm, how can mm, how can I say that? Yeah, ad hoc development means suppose I have given one program to four students, right? Now four students have done the program, but they have implemented different logics. This is called as ad hoc development, right? And second one is systematic development. Systematic development is always uses the optimized logic, and it will optimize your program. Here the complexity can be high in ad hoc, whereas in systematic development complexity will be optimized, correct? So from yeah, so next part we'll study on next day. That's it for today. Get ready for the next. Okay, thank you.